I'm America's Digital Pro, Kim Komando. And in this Komando On Demand podcast, it's a little bit different. We're going to examine how technology is so critically important to the future of the American farm. I bet you it's something that you never really thought of. We're going to talk about self-driving tractors and drones that monitor the fields. And that's what I love about doing these Komando On Demand podcasts. We speak with industry movers and shakers, and we keep you up to date on everything digital, even things like this that you may have never thought of. But first, I'd like to give a shout out and a quick thank you to our partners whose support helps make this podcast possible. If you look back in the history books, it's all loaded with stories about Americans living on farms and ranches. And that all changed a little over a century ago. People started moving into the cities. That became the majority. The number of folks living in small towns and farms, it continues to decline. Today, only 20% of us actually live in the heartland. But agriculture still adds over $150 billion to the economy every single year. That's huge. And that number is even more impressive when you realize that only 2% of all Americans actually work in agriculture. So farming definitely had to change. And it certainly did. It became heavily dependent on technology. We're talking about enormous tractors that are guided by GPS systems. They're pretty commonplace these days. Okay, do you know what that sound is? No, silly. It's not the sound of a motorcycle. That is a fixed-wing drone used by a gentleman by the name of Robert Blair. Robert is a fourth-generation Idaho farmer. After getting his degree in business, he returned back to the farm. But he was convinced that the old ways, well, they just had to change. So he's dedicated his life into bringing the family farm well into the 21st century. A few times a week, he sends his little drone right into the air, and then he scans his fields for any potential problems.
Yeah, I can tell you exactly the month and year. It was July 2006. I was reading through Crop Life magazine and saw an ad for a drone in there, called on it, and the rest was history. So I've been using them since 2006.
As you might imagine, being a fourth-generation farmer, there are a lot of folks around him and in his family, maybe a circle of friends. They're not really as passionate about dragging American agriculture into the 21st century.
That's why I got it. In 2004, I was in a manned aircraft flying over my farm for the first time. I'd been doing precision ag, started in 2003 with a yield monitor and that, and saw that that was the missing link, was having good real-time imagery. That was the missing puzzle piece. I had never heard of a UAV.
So, Robert, let's talk at the very beginning. We've all seen drones. We know what they can do, especially in real estate, for example. When we start talking about farming and drones, it gets a little sketchy for most of us because we live in the cities. So how exactly are you using drones?
Well, for me, it's not necessarily day-to-day as it is having those flights at critical and crucial times. So for a winter wheat crop, you would first start your flights, let's say, between February and March, right in there as snow leaves and it's coming out of dormancy to see how good the stand of crop is. And then looking at it, where do I need to put fertilizer? Do I have weeds coming out?
Now, I will tell you here at the beginning, Robert, I don't even have a garden because, well, that's just not my forte. But I would imagine scanning fields for signs of weeds or bugs or infestations, it has to be really important for a farmer. But ranchers are also adopting to this technology, say herding animals on these enormous plots of land in Idaho or Texas. It's not that easy with four-wheelers and pickup trucks and horses. So ranchers are actually turning to quadcopter drones to monitor and herd their animals too.
Oh, yeah. Being able to utilize drone technology for livestock management, sheep and cattle doing grazing, and not only the livestock, but the areas they graze is very important and will be more important as we move forward.
Okay, this is pretty slick. Being able to herd animals into pens, or it's a neat trick that drones can accomplish, but they can do so much more than that. Listen to this. A drone outfitted with a heat-sensing camera can track animals in the dark, or maybe even a snowstorm. It could also detect if an animal is sick by reading its increased body temperature. And Robert says There's no reason why that facial recognition software couldn't work just as well on cows as it done on humans.
And if we take a crystal ball and look into the future, if we take a look at Facebook where it's at now and we can do face recognition, why can't we do that with a drone and our cows or sheep? That's where the future of this is heading. We can utilize thermal imaging to see where animals are at in brushy areas.
Now you have to remember, a herd is like cash being out in those fields. So keeping a close eye on your herd is actually really important, especially if you're worried about these modern-day cattle rustlers.
And I've had conversations with law enforcement asking those questions through the years. Can we utilize this technology to catch, not poachers, rustlers, cattle rustlers in snowstorms? So those are some of the things we could look at.
But I have to say, using drones to herd livestock, it's not yet the preferred way for ranchers. Recently, the BBC tested their effectiveness on a herd of sheep in Ireland. They pitted an experienced shepherd and his favorite sheepdog against a quadcopter. Oh my gosh, could you imagine? So make a guess. What would have been better to manage this herd of sheep? After 2 different tests, dog versus machine, they were tied at 1 win apiece.
Right, this is round 3, the ultimate deciding round to see who's the winner. Much more complicated. We're going to get the sheep driven down, hopefully through one set of gates, then across the field, through the other set of gates, and then hopefully through the opening at the bottom.
First up, it's the drone.
Stay to one side of him. Go behind him, we'll go back to the corner, quick, quick, quick.
I have to say a cumulative time of about 7 minutes 30. Let's see how the dog gets on. And that's it. 3 minutes 57. Dog definitely beats drone. What a performance. Well done, Joe. Well done, Gary, wherever he is. Top job.
In the end, and in as much as I love technology, I actually liked that this 1,000-year-old technology of man and dog actually prevailed. But the drone did a really good job too. A future where whole herds of livestock are managed by drones is likely not too far off.
We are just at the tip of the iceberg with the technology, and this one of the sad issues is most of the companies out there, from sensors to platforms and software, have gone after the low-hanging fruit instead of creating the solutions that the agriculture industry needs, both from a crop and livestock perspective.
All of this might sound great for ranchers and farmers, but there are important benefits for consumers too. Knowing where your food comes from is increasingly important for Americans. I mean, right now, farm to table, it's this fashionable phrase for trendy restaurants. But imagine a future where you could actually track the entire life of the food that you're eating. That's not so outlandish, according to farmer Robert Blair.
This is the direction farm programs are going. This is also the direction consumers are wanting. What is our food? How is it raised? And is it sustainable? And the technology that we have today can help us go down that path.
Technology could revolutionize agriculture in this country, but farms, they've been slow to adapt to the changes. The average age of a farmer in this country is 59 years old, and government programs haven't really stepped up to the plate. They've been really slow to encourage farmers to, say, adapt more rapid changes.
The average age of a farmer is 59 years old. They control the resources and the money. And when you take a look at that and think about it, they have the money. They're getting ready to retire. Why do they want to learn something brand new?
You mentioned that consumers want more sustainable and more transparent food production. I see that all around me myself. But let me ask you a question. Has big business been helping to really achieve that?
Private industry, like the Walmarts, McDonald's, make a significant push and monetary contribution, I think, to agriculture to help make this happen. If their customers are wanting it and to trace sustainability, why aren't they paying the farmers and helping them find those solutions?
When you cut through all the clutter, why do you think they've been slow to help?
I mean, you take a look at Verizon and IBM, they're saying we have these solutions to make rural America connected. But when you look at the IBM commercial, they're showing an old farmer in coveralls with an outdated tractor going out to the field. No cab or anything. That is not today's agriculture. That is the image of American Gothic.
One new technology that's poised to totally change the way food is grown in this country is autonomous vehicles. All right, sometimes they're called self-driving cars, and they're expected to take over our roads within the next few years. Well, hot on their heels, are you ready for it? Self-driving tractors. And I personally am excited about self-driving tractors. A couple of years ago, I visited a friend of mine, Chip Davis. I went to his farm in Nebraska. And you may know Chip Davis as the founder of Mannheim Steamroller. Chip has this amazing farm in Nebraska, and he has this huge John Deere tractor. So in the way that Chip does, he lifted me up. He's kind of a big guy. Put me up on the tractor and said, "Okay, go plow the fields." I looked at him like, how does that work? Let's just say I was kind of the bucking bronco in the tractor, if you get my drift. Couldn't quite get that drive thing down. So I'm really hoping that the next time I go to Chip Davis's farm outside Omaha, Nebraska, he's got a self-driving tractor. I'm going to tell you more about that, so stay right where you are.
This autonomous tractor concept, conceived by CNH Industrial's innovation team, is truly independent and driverless. It is controlled and monitored remotely, freeing up skilled labor which can be redeployed. It offers the possibility of true 24-hour working, eliminating operator fatigue and enabling a different approach to fieldwork.
There have been a lot of attempts over the last 20 years to bring these self-driving tractors to market. But what's interesting to me is John Deere. Of course, that's the big name. They've been working on this technology since the 90s, and it hasn't been easy. Unlike navigating a road, think about this. Figuring out when to start, when to stop, when to turn left or right in a wheat field, it's a lot more complicated. And then there's dust, there's wind, mud. It's something that a human has to deal with. Well, John Deere, Case IH, and other companies, they've been using a variety of solutions to get around these problems. We're talking about some really high technology that's on the farm. They're using a combination of lasers, GPS signals, and pre-programmed maps. And there are a lot of tractors already in use that have some self-driving features. We're talking about maybe something like a dual correction GPS. In case you've never heard of this, this allows farmers to plow incredibly straight lines to make sure that no seeds and no chemicals are ever wasted. These tractors still need a human being, though. That's right, the farmer has to sit in the cab to make the turns. John Deere's head of intelligence solutions told The Verge in 2016 that the next step is to remove the farmer from the cab completely.
If you start from the fact that a lot of farming is very manual, very intensive, and the age of our farmers continues to grow, it's a tool that helps them gain productivity, gain efficiency, reduce the amount of overlap they have in the field, and overall produce more crop with less dollars. So our largest machines would be 120 feet wide, 48 rows at a time that they'd put into the ground. They can cover 400 to 500 acres a day. Vehicles and the systems that we use are a combination of embedded technology, that technology that sits in the vehicle, mobile technologies that people carry in and out of the cab, and then we also have a full suite of cloud-based services. So those vehicles are networked together. They both guide themselves, but they communicate back and forth across various vehicles. They also communicate and deliver the data about what's happening in the field in real time back to an operations center that every producer can log on and see from wherever they are in the world in real time.
So there are a lot of companies that are feverishly working to create the autonomous farm. One of them is the North Dakota firm called Autonomous Tractor Corporation. The company's co-founder, a guy by the name of Carl Schultz, says that there's a big debate about how this technology will actually work on the farms.
I think there's different views on what the ultimate goal of automation is. There's some people who think that the quote-unquote automated farm is going to be waking up and having your second cup of coffee and watching your tractor pull back into the barn after it's done with its work. I think that notion is still a long ways off.
A kind of self-driving technology called GPS-guided steering has been in use for, say, 20 years on America's farms. Carl says farming is going to have to be this high-tech business. Really, why? In order to survive.
There are a lot of incremental improvements in autonomy that are starting to hit the scene now. Some of the technologies that sense difference between the plant and the weeds and can spot spray. You have the drones that are starting to do analytics on crop growth, infestation, that kind of thing. And I think it's going to continue at a fairly rapid pace for the foreseeable future.
I have to tell you, a lot of people that I speak with, they're totally nervous about self-driving cars. They don't trust them. So when we start talking about farmers, are they going to be willing to use self-driving tractors?
Yeah, I don't think that farmers are reluctant to adopt technology. They're actually pretty technologically savvy. You look at it, trying to even use some of the modern equipment like a combine or a planter, it is a technological wonder how advanced those things are. And farmers are very adept at adopting and integrating new technologies.
The big farm companies have been working on developing a self-driving tractor for a really long time. But I guess my question is, why has it taken so long to actually develop it?
The resources that one can throw at it in the automotive sector are much higher because the volumes are so much higher. So you're only talking a handful of companies that even operate in the tractor space, and their R&D budgets aren't going to even come close to the R&D budgets in the automotive world. So there's certainly that part of it. It's a relatively small segment.
And I get that. It's harder to develop self-driving technology for something that, I guess you'd say, primarily operates off-road?
A car is designed for one purpose, and that is to transport people and things from point A to point B. A tractor is not designed to do that. In fact, tractors don't really do any of the actual work in the field. It's all the implements. So a tractor can be attached to anything, a baler, a planter, spraying mechanisms, and it's the thing that it's attached to that actually has to do the work, and that work is relatively complicated. It's the essence of farming.
So when we're talking about farms, it's less about the driving and more about operating the implements.
The burden in some ways is much higher when you're trying to perform a task that takes even an adept individual decades of learning to actually know what they should be doing, where and when in a farming operation.
There's no doubt programming a tractor to drive around a field is a lot more difficult than driving on a highway.
In a car, if you think about how you navigate in a car, you're using primarily your eyes, right? There are things to see, curbs, roads, stop signs, other vehicles. And in most situations in a farm, you don't have that. There's really nothing to see.
Now that's interesting. What kind of technology is being developed for that?
When you start talking about removing the driver from the cab, there's a good reason why none of the automotive companies are using GPS to steer cars. It's just simply not accurate, reliable, or repeatable enough to do that safely and effectively. So we still have some room to go in how we navigate a tractor through the field.
Because GPS isn't accurate enough to navigate around a field, manufacturers have had to turn to other solutions. First, let's talk about lasers. Lasers fixed to each tractor will bounce a signal off of the transponders, and then these transponders are positioned all around the field. So instead of having a driver in each tractor's cab, there's a human controller located nearby. The whole idea is that one human being can control multiple tractors at one time. Other proposed systems use the information gathered by overhead drones to guide the tractor. In this case, the tractor is equipped with something called a LiDAR. You know what that means. Of course you do. You listen to the Komando show. All right, between us, it's a laser-based radar. That's right, a LiDAR. And it's on there to avoid all the obstacles. So, Carl, what do you think is the biggest advantage of automated farms?
The real need for automation is that there's a couple of times during the year when the labor requirement exceeds our ability to put qualified laborers into the field. It's just a very hard problem to solve from a labor standpoint.
Certainly, there's more than just people driving tractors on farms. I mean, what kind of jobs could also be automated too?
One way to think about it is having the ability to do things in parallel that used to be done in serial, meaning you can do more things simultaneously in the field with the same or even less labor than you used to have.
So instead of replacing the farmer, the technology could actually be like another worker. And that's pretty cool.
So another way to think of it is, well, what if we don't use scale, but instead we use automated pieces of equipment that lend a helping hand? Rather than trying to replace the farmer or the labor, it's adding additional capacity to the labor that's already going to be in the field. And that's a very different kind of automation. We call that semi-autonomous.
How would that semi-autonomous equipment actually work? Tell us more.
But you could imagine a world where the farmer is driving the combine and there's a baler running behind the combine that is actually, he's not operating it. It's running autonomously, gathering the stover and baling it on the fly. So that he's doing two jobs at once, even though he really is out there to combine because that's his primary goal. He can supplement his own labor with a semi-autonomous piece of equipment that's doing another task.
What do you think the biggest advantages are? I mean, if we put all this technology on our farms.
One of the most important things on farmers' minds today, especially given the current crop prices that we see, which are historically quite low, they have to cut costs in order to make money. And if there are ways that they can save money either through less labor or through more efficient and cheaper equipment, they will jump at the chance.
So it's about reducing costs, which would be great when we start talking about all the government and tariffs and regulations that come into play when we start talking about farms.
If the technology designers like my company can come up with a very cost-effective solution that adds to their capabilities while reducing costs, it's a big win for farmers because they're looking everywhere to save nickels and dimes.
Now, Brian, what did you think when you heard about a self-driving tractor?
When I first heard about that, and I said not only no, but heck no, it's not going to take off. I said the same thing about email when it first got Windows 95. You know, I'd rather talk to someone face-to-face, telephone, and then I'll write a letter. Okay, well, that's changed in those years since 95.
What changed your mind?
We could do it autonomously and work around the clock 24 hours. We could map areas to where we could work or need to stay out of that are too wet and use the technology to farm smarter. We are heading in that direction.
So does that mean that a fully automated farm will be possible soon, say one day?
And that's where drones can come in, flying ahead of time, mapping out those wet areas and say, hey, you need to stay away from here and farm around this. And so that farm of the future, it will be automated in about 20 years.
Brian was probably the first farmer in America to use a drone. That was back in 2006. In the decades since then, he's been pushing manufacturers, governments, and other farmers to totally embrace the technology. He believes that drones need better visual sensors to be able to detect things like, say, wet spots on the fields. And the only way to get manufacturers on board is to get government agencies like the USDA to push for better equipment. Brian was recently in D.C. working with a group called the AG-ARS Council. Their goal, among other things, is to set these better standards.
What is the proper camera? What type of lenses? What nanometers should things record at? How should we fly things? Are we correcting for atmospheric issues? And what does that look like? And start creating this matrix table of, okay, if you have this type of drone, fixed wing, multi-rotor, this type of sensor, and utilizing this type of software, this is what you can expect it can tell you.
So has all the effort to develop this amazing technology? I'm sure it's been worth it, but tell us more.
Being able to hedge against risk. I'll take an example from 2015, and then it turned off really dry. We had a drought from June 3rd to September 1st. We had no rain. I still maintained my yield. Not only that, my quality of my wheat was spot on. And so the technology is more than paid for itself.
If you had a crystal ball, What would your vision be for the future of this technology?
I have all this data set from 2004 to present. I'm not utilizing probably even a tenth of what I have to the capacity compared to the field records and weather data. But I have that information available, so when the time comes, I have a history that we can use to hopefully predict the crops of the future.
Carl, your company is developing autonomous farm equipment because you think it's going to make farms more profitable. Do you think it's also going to make farming, say, more productive?
Being able to more precisely place the seeds, care for the seeds and the plants, and harvest them by having more precision equipment. It can reduce our input costs. It can reduce the amount of environmental damage that is done through overspraying of chemicals. It can reduce waste.
And that's part of the debate. Automated technology. Is it actually more efficient than, say, a human-operated system?
When you're controlling something with a computer and motors that can manipulate the soil or the seeds or the chemicals with a high degree of precision, that will help to increase yields and cut costs. And yes, I think all of that will play a fairly major role in continuing to improve the overall productivity of agricultural operations.
Incorporating technologies like aerial drones, self-driving tractors, and advanced sensors will definitely make farming more productive. And so the next time you're driving through the highways and byways, or maybe you're even visiting the heartland, or you go see a farm near you, just keep in mind that all this technology is suddenly now making its way to the farm. I'm Kim Komando, and you've just listened to Komando on Demand, and I really hope that you enjoyed this podcast. And if you did, for the sake of the farmers, of course, make sure that you give us a nice 5-star review and some nice words over at iTunes, Google Play, or wherever you get your podcasts. And a special thanks to our guests in this podcast, Robert Blair and Carl Schultz.